March 14, 1879. A child is born in a small town in southern Germany. He's slow to talk, so slow that his parents fear something is wrong with him. His teachers will later call him dull. One will tell him directly, "Nothing good will ever come of you." That child would go on to rewrite the laws of the universe. This is the story of Albert Einstein.
Freut es Sie hier in Amerika wieder zu sein? Wenn ich Sie sehe, sicher.
Einstein was born in Ulm, Germany, a mid-sized town on the Danube River. His family are secular Jews. His father, Hermann, is an engineer and salesman. His mother, Pauline, is sharp, witty, educated. Not a poor family, not a rich one. Comfortable, ambitious, and always one business deal away from disaster. Hermann and his brother Jacob kept starting electrical equipment companies, Munich, then Italy, and they kept failing. The family uprooted multiple times, chasing opportunities that never quite landed. So Einstein's childhood is actually marked by instability. New cities, new schools, always the outsider. Age 5. Einstein is sick in bed, and his father brings him a compass to pass the time. Most kids would play with it for 10 minutes and move on. Einstein was transfixed. He kept turning it, watching the needle always swing back to north no matter what he did. And it disturbed him, in the best possible way. He later described it as a profound and lasting impression, because he wanted to know, what force is doing that? Clearly this is a brilliant kid. School must have been easy for him? The opposite. He hated school, not because it was hard. He was teaching himself algebra and calculus by age 12. He hated the method. German schools at that time ran on strict rote memorization and military-style discipline. Sit down, repeat after me, don't ask questions. And Einstein was built entirely the wrong way for that system. He needed to wonder. He needed to ask why. The system wanted him to just absorb and obey. At 15, when his family moved to Italy for yet another business attempt, he was supposed to stay behind in Munich and finish school. He didn't. He used a doctor's note, claimed nervous exhaustion, and got himself released. Then he walked out and joined his family in Pavia, Italy. A 15-year-old dropout, no diploma, no plan, and completely free for the first time in his life. In Italy, free from the rigid school system, Einstein flourished. He roamed the countryside, read philosophy, thought deeply, and wrote his very first scientific essay at 15. On the investigation of the state of ether in a magnetic field. A 15-year-old. No teacher, no assignment, just a question he couldn't stop thinking about. Einstein believed himself. He later wrote that the school's method of rote learning was actively harmful to creativity, and his life was almost proof of that. Einstein also played the violin from childhood, and he was genuinely good. Not just as a hobby, he played seriously his entire life. And there are accounts of him getting stuck on a physics problem late at night, picking up the violin, playing for a while, and then suddenly stopping and saying, "I've got it." The music and the physics weren't separate. They fed each other. He once said if he weren't a physicist, he would have been a musician.
Relativity that mass and energy are both but different manifestations of the same thing.
1902. Albert Einstein is 23 years old. No university position. No professor will recommend him. Rejected across Europe. So he takes a job examining patents in Bern, Switzerland. Third-class technical expert. He reviews other people's inventions 8 hours a day. 3 years later, that same patent clerk will publish 4 papers in a single year that collapse everything physics thought it knew about the universe. In 1903, he married Mileva Maric, a fellow physicist, one of the few women studying science at that level in Europe at the time. She had been his intellectual companion through the years the miracle year was being built. Some historians believe her contribution to his early work was never fully acknowledged. Einstein had been carrying a question since he was 16. What would it look like to ride alongside a beam of light? Between March and June of 1905, Einstein wrote 4 papers, each one a revolution on its own. The first proved light travels in discrete packets of energy, quanta, so radical it wouldn't be accepted for 20 years. It would eventually win him the Nobel Prize. The second proved atoms exist, settling a century-long scientific debate with mathematics. The third was special relativity, built on 2 simple ideas. The laws of physics are the same for all observers, and the speed of light is always constant. From just those 2 assumptions, everything followed. Time slows down the faster you move. Space contracts at high speeds. The universe Newton had described was gone. In its place, something stranger and more true. Then, almost as an afterthought, a 4th paper. 3 pages. His famous equation, E equals mc squared. Mass and energy are the same thing. A tiny amount of mass contains an almost incomprehensible amount of energy. Written at a patent office desk. No lab, no team, no funding. 1905 wasn't a miracle. It was a decade of questions building in one mind, finally breaking through. A 16-year-old's thought experiment about light carried through rejection and years of patent work, until one year it all came out at once. The universe had been rewritten, but the man who rewrote it was about to face a fight he didn't see coming. In 1919, the same year the world confirmed his greatest theory, Einstein divorced Mileva and married Elsa Lowenthal, his cousin, twice over. In fact, she was both his first and second cousin, depending on which side of the family you traced. It raised eyebrows then. It raises eyebrows now. But Einstein, the man who had rewritten the laws of the universe, seemed entirely unbothered by the opinions of others. By 1927, Albert Einstein was the most famous scientist alive. Relativity had made him a legend. Newspapers followed him everywhere. Crowds gathered just to see his face. While Einstein had been busy with relativity, a new generation of physicists had been quietly dismantling the universe at a smaller scale. Quantum mechanics, the physics of the extremely small, was emerging, and it was strange in a way that made even relativity look comfortable. The central idea, developed by Niels Bohr and Werner Heisenberg, was this. At the subatomic level, particles don't have definite positions or speeds until you measure them. Before measurement, they exist as a cloud of probabilities. Reality at the smallest scale is fundamentally uncertain. Einstein hated this, not personally, not out of stubbornness. He hated it because it violated his belief that the universe follows precise, knowable laws, that God, as he put it, does not play dice with the universe. In 1927, the greatest physicists in the world gathered in Brussels. Every morning, Einstein arrived with a new argument to prove quantum mechanics was wrong. Every evening, Bohr dismantled it. Then in 1935, Einstein made his boldest move, the EPR paper. 2 particles separated across any distance, he argued, couldn't instantly affect each other. The universe couldn't be that strange. He called it spooky action at a distance, and he meant it as a criticism, and he believed that quantum mechanics was incomplete. Niels Bohr disagreed. He argued that the world truly behaves this way, fundamentally probabilistic and non-classical. Decades later, experiments proved that the quantum entanglement is a real phenomenon, and Einstein was proved wrong.
Hydrogen bonds appear on the public horizon as a broadly attainable goal. Its accelerated development is following the proclaimed by the President. Is successful.
Ladies and gentlemen, it is a pleasure for me to receive this sign of appreciation and kindness from the Technion in Paris.
Einstein spent the last 30 years of his life chasing a unified field theory, a single equation that would tie together gravity, electromagnetism, and quantum mechanics into one complete picture of reality. He never found it. He died in 1955, still searching, unfinished notes on his hospital bed. But here's what he left behind. Every time you use GPS, the satellites overhead are correcting for the time dilation Einstein predicted. Without that correction, your maps would be wrong by kilometers. The nuclear reactors that power cities run on E=mc². The gravitational waves that LIGO detected in 2015, ripples in space-time from colliding black holes a billion light-years away, were predicted by Einstein a century earlier, almost to the detail. Black holes, the expanding universe, the Big Bang, all of it traces back to equations written by a man who once failed to get a university job. He never finished his final theory, but the framework he built, the questions he asked, the way he thought, still shapes every corner of modern physics.